topic before you start your assignment on Wednesday. You've got week 9 of no lessons, so chill out on that. Focus on the thing that you're doing. Week 10, you'll work on the assignment solid, and please don't do any holiday homework. Your holiday is for you, okay? Your level of ability in this class, you'll have plenty of time to do it in class. So can I review? Objects are similar if they are the same. Objects are similar if they have the same, what, size? That's congruent. Same shape, but different in size. One can be bigger, one can be smaller, they're similar. Scale factor is the measure of how many times the dimension of an object has been multiplied. For example, the two cubes below are similar to each other. What do you notice has happened to all the dimensions? One's 2 by 2 by 2, the other's 4 by 4 by 4. What did I do? Times by 2. So the scale factor is 2. Can I give you some moments to get that down? Because you're going to be hammering the idea of scale factor in this assignment. How many times? 16 times.
Whose was that?
So hopefully you agree that we could just find the surface area and volume of these objects individually by doing repeated calculations. So what would the surface area of the small cube be? Well, one side would be 2 by 2. So 2 times by 2. And how many sides are there in a cube? 6. So 2 by 2, 4 times by 6, 24 square centimeters. And then the volume is going to be 2 times 2 times 2, which is going to be 8 cubic centimeters. And then I have a larger cube, and I could do the same maths for that. Surface area is going to be 4 by 4, and there's 6 sides. And my quick maths in my head doesn't extend to that. 4 times 4 times by 6, 96 square centimeters, and 4 by 4 by 4 is going to be 64 cubic centimeters. We could do that. You don't need to copy that down. This is for illustration. Because, is that a question? You can say.
Never mind. I got math.
Yeah. If 3D objects are similar, instead of doing that, because I'm warning you now, to pose our argument in your assignment, you're going to be doing 8 scale factors. I don't want you to have to do this 8 times for a baby shape that's going to have at least 6 separate pieces. Could you agree that if that was the case, then you had to do it like this, there would be a lot of maths, repetitive maths. We need a shortcut. That's why I gave you the Year 11 General Maths exercise, because there's a shortcut. Why not just teach it? So if 3D objects are similar, we have a shortcut to find the surface area and volume of the objects, as long as we know what the scale factor is. So get these 2 shortcuts down. New surface area is equal to k squared times by the old surface area. And new volume is equal to k cubed times by the old volume. And in both formulae, k is the scale factor applied to the old object to get the new one. Get that box. You're going to be hammering that for your assignment. And I'll just give you an example.
Is it times?
Yep, just k squared times by the old surface area and k cubed times by the old volume. Question?
No, I just need the charger.
Oh, yeah. You'll know what I mean when I say OG, right? It's the original.
Original gangster.
So let's pretend the starting shape for an assignment was a rectangular prism that had width, length, and height of 3 centimeters, 10 centimeters, and 3 centimeters. What's the surface area of this shape? SA is going to be, the long sides are going to be 3 by 10, and how many of those long sides will there be? 4. So that's going to be 30 times 4. It's going to be 120 square centimeters. Are they the only sides of this shape? We've got 2 squares on the end. So that's going to be 3 times by 3. And how many of those are there? 2. So 9 times by 2. 9 times 2 is going to be 18 square centimeters. So together, 138 square centimeters. The surface area. Volume, this is a little easier. 3 times by 3 times by 10. 990 cubic centimeters. So I'm going to put boxes around those because they are the OG. And the reason why the OG is important, because your shortcut is the OG times by whatever your scale factor is squared, or the OG volume times by whatever the scale factor is cubed. So find the surface area and volume of this shape if all the dimensions were tripled, scale factor of 3. So the new surface area is going to be scale factor of 3, so K is going to be 3. And in your shortcut for surface area, what was it? Was it squared or was it cubed? Squared. Times by the OG, which was 138, which will be 9 times 138, 1242 square centimeters. Do you agree straight away that that's a bit quicker than having to find the surface area of the shape when it was 9 by 9 by 30? I don't have to draw a whole new diagram. I just went, I know that this is the starting one. I know that all the sides are increased by a scale factor of 3. Use my shortcut, I found it. What's the shortcut for volume? New volume is going to be 3. Is it squared for volume or cubed for volume? Cubed for volume times by, the volume is 90 of the OG. Please don't use 138 because that was in terms of surface area. 3 times 3, 9 times 3, so it's 27 times 90. 27 times 90, 2430 cubic centimeters. Okay? So right now it's because you haven't started the assignment, it's not clear why you need to have the shortcut. But what you're basically going to be doing is you're going to come up with something that's vaguely baby shaped. And you're going to research like the dimensions of something that's baby shaped. And then you're going to scale it up in size to pretend to be an adult in size by increasing the scale factor. Do you really want to have to do that, this, for something that has a sphere for a head, 2 arms, a torso, legs and feet? Or if you worked out what the OG volume was and you just do this, you can find all the little scaled up sizes from baby size to adult size. There's a reason for that, to pose our argument, but that's basically it. We don't need to do the last example. Can you please do exercise 8E? And then we start the assignment on Wednesday. Yeah?